It's a question of chapter test, question number 6, second part. First, I will take A common from the first row. I get A plus x by A, B and C. Then I take B common from the second row. I get A, B plus x by B plus C. And then I take C common from the third row. A, B, C plus x by C. This is equal to 0. And A, B, C is here, common. Now I'm going to multiply the first column with A, second column with B, and third column with C. Then I have to write by ABC. So when I multiply this, becomes A square plus x by A into A is x, A square, A square. Similarly, B square plus x, B square. And here C square plus x is equal to 0. When I multiply, I have to by ABC also have to write. Now C1 plus C2 plus C3. If I add this plus this plus this, this plus this plus this, this plus this plus this, I get here. Next step, I'll take this as common. I take common, I get 1, 1, 1. Once you get triple 1 means your solution is almost there, because you have to make 2 ones zeros. After this, I'm going to use R1 is R1 minus R3, R2 is R2 minus R3. That is, this minus this, this minus this is 0, this minus this is 0, and this minus this is minus x. Similarly, R2 is R2 minus R3. This will remain same. Expansion along R1. I'm going to expand it along R1 because minus x is there. So this I'm going to copy it, minus x into this. This and this is out, 0 into this, minus 1 into x. I get this equal to 0. I have not written equal to 0. I'll write here equal to 0. So x is 0, x is equal to minus a square plus b square plus c square. This is a complete solution. So the first example, I'll take a common from the first row. Minus a square becomes minus a, ab becomes b, and ac becomes c. B common from the second row, ba becomes a, minus b square minus b, and bc becomes c. And c common from the third row, a, b, and minus c. Now I'll take a common from the first column, minus 1, 1 and 1. B common from the second column, 1, minus 1, 1, and c common from the third column. After I get this, since my aim is to get maximum zeros, so I will write R1 is equal to R1 plus R3. Minus 1 plus 1 is 0. 1 plus 1, 2. And 1 minus 1 is 0. After taking A, B and C common, this ABC becomes A square, B square, C square. Now I'm going to expand it along the first row. This 2 is minus 2. I remove the first row and the second column. I get 1, 1, 1 minus 1. This is minus 2. Minus 2 into minus 2 is 4a square, b square, c square. This is the first example. So this is the question. The first step aims at making maximum zeros in the first row. So I use C2 is equal to C2 minus C1. 1 minus 1, 0. B square minus a square and b cube minus a cube. Then C3 is equal to C3 minus C1. 1 minus 1, 0. C square minus a square, c cube minus a cube. I take b minus a common from here and c minus a common from here. B minus a into b plus a is b square minus a square. B minus a into b square plus ab plus a square is b cube minus a cube. Similarly, c minus a into c plus a is this, and this into this is this. Now C2 is equal to C2 minus C3. to make it more simpler. B plus A minus C minus A is B minus C, and this minus this is this. After factorizing this, B square minus C square is B minus C into B plus C, here A common. I take B minus C common here. Now the next step, I take B minus C common from the second column in the next step. Next step, after taking B minus C common, I get this. Now expanding along the first row, I'll eliminate the first row and the first column. 1 C plus A, this and this I get. Then this into this, minus this into this. If I calculate, I'll find I get minus AB minus BC minus AC. Minus common here. B minus A I'll convert to A minus B, taking minus common. Minus into minus is plus. So this is the proof, final proof. So I'm going to multiply the first row with Z, second with X, and third with Y. By multiplying I get this. Z into xz square and z square y. Similarly this with x. When I multiply, I have to divide also. So 1 by x y z. Now I'll take common z from the first column, x from the second column, and y from the third column. I remove all z, I get this. By taking common x from column 2 and y from column 3, this is common. This by this is 1. Next, C1 is C1 minus C3. This minus this. This minus this. X square minus x square is 0, and y square minus x plus z whole square. And C2 is C2 minus C3. Z square minus z square is 0. This minus this here and this minus this here. When I use the formula A square minus B square, it is A plus B into A minus B. Here also A plus B into A minus B. Here also A plus B into A minus B. Here also A plus B into A minus B. Then you'll find x plus yz is common from here, first column, and x plus yz common from the second column. X plus y plus z whole square. This remains here, 0. Here this remains. Here this is out, this remains, and here this remains. And this is as it is. Now next step. Next step is R3 is R3 minus R2 minus R1. R3 is R3 minus R2 minus R1. If you see here, this minus this minus this, y minus y cancelled, minus z plus z cancelled, and minus x is minus 2x. This minus this minus this, and this minus this minus this. Similarly, what I get? I get here minus 2x, minus 2z, and 2xz. Now, this is the most important step. My aim is to get 0. So, this plus 1 by z into C3. If I remove z from here, minus 2x plus 2x is 0. That was my purpose. Similarly, C2 is C2 plus 1 by x into C3. Minus 2z plus 2z is 0. Same operation I am going to do with these two elements also. And I get this. Now I am going to expand it along the third row. This is whole square. 2xz I am going to copy and remove the third column and the third row. I get this. And on multiplying, here I get this. Here y common I'll take 2xyz, and finally I get the proof. So one more important question. First I'll take x common from the first row. I get 1 by x, 1 by x, 1 by x plus 3. Y common from the second row. 1 by y plus 3, 1 by y, and 1 by y. And z common from the third row. I get 1 by z, 1 by z plus 3, and 1 by z. This you need to write also. So, then x, y, z. I write here R1 is R1 plus R2 plus R3. I get 1 by x plus 1 by y plus 1 by z plus 3. 1 by x plus 1 by y, 1 by z plus 3. 1 by x, 1 by z, y, 1 by z plus 3 will remain same. I'll take common. One and 1. Here 1 by y plus 3, 1 by y, 1 by z. Now, once you get 3 ones, your problem is almost done. So C1 is C1 minus C3, C2 is C2 minus C. This I'll do in the next step. So C1 is C1 minus C3 and C2 is C2 minus C3. Then I get here 1, 1 minus 1, 0, here 0, here 1. This is 1 minus 1, 1 minus 1, and here 1 minus 1. Here I get 3, here 0, this will remain the same. Here I get 0, here I get 3, here will remain same. Now x, y, z, this is 1 by x, 1 by y plus 3. I'll expand along the first row. So first row and third column is out. What is left is 3, 0, 0, 3. Here x, y, z, I'll take x, y, z common, then here I get x, y plus y, z plus zx plus 3x, y, z. And here on same 3, 3 is the 9. Finally, I get the answer 9 into 3x, y, z plus xy plus yz plus zx. This is proved.